In these problems, we are using something called the Intermediate Value Theorem. And this is the theorem right here. I'm going to read this and then I'm going to try to maybe draw a picture to explain it better. It says, if the function f is continuous on some interval a to b, and f of a does not equal f of b, so the function actually changes, it goes someplace between a and b, and r is a number between f of a and f of b, then there exists a number c in the interval a to b such that f of c equals r. So that's a lot to take in. Let me try to draw a picture to explain this. So we've got some function doing something, and we're going to choose an interval. So let's say this is a, and this is b over here. So this point right here, the y value would be f of a, and here the y value would be f of b. So as long as we know this is continuous, we know that there's some number that's between these two numbers, f of a and f of b, that satisfies some point f of c is going to equal that number. So for example, let's say we're looking for whether this crosses 0. If you are able to evaluate that the function on one end is positive, on the other end is negative, you know there's some point where it's going to have to cross that 0. It can't get from positive to negative without crossing through 0 if the function is continuous. So that's the basic idea between the intermediate value theorem. In this problem, they kind of walk us through a lot of reasoning about that to help us think about it. So let's see how this goes. It says, consider the following equation, 7 over x plus 2. So we've got a rational equation here. Obviously, this equation is not going to be continuous everywhere. At 0, at x equals 0, there's going to be an asymptote there. So we have to keep that in mind. And it says, answer the following to determine if we can apply the intermediate value theorem to show that the equation has a solution in the interval -9 to -3. Okay, so -9 to -3, that's a good interval for us because that's not where x is 0. That's before we get to 0 on the x. So that's good. We know it should be continuous there. And that's actually our first question. Choose the statement that best describes the continuity. F is continuous on 93 because it is a polynomial function. Well, that's not true. It's not a polynomial function. F is continuous on the interval -9 to -3. That is because f is a rational function, and while there are values of x where the function is not defined, those values do not lie in -9 to -3. That's correct. And the other choice is it's not continuous, but this one is. Okay. Now it says find f of 9 and f of 3. Well, that's not too hard. The function is 7 over x, so -9 would be -7/9, and then there's a plus 2. I'm going to write the 2 as 18/9, and that's going to be then 11/9, positive 11/9. And then let's plug in -3 for x, so 7 over x plus 2, I'll write that as 6/3, and that's going to be -1/3. This is good. We see that one of them is positive, one of them is negative, so we know for sure it's going to cross 0 to get from one to the other. This part here, what they want you to put in here is the not equal sign. That's part of the theorem too. We need to know it's continuous. That's what we just proved here. We need to know that f of a and f of b are not equal to each other, and they are not. And now we're going to look at whether they're greater than or less than 0. F of -9 is positive 11/9, that's greater than 0. F of -3 is -1/3, that's less than 0. So we know this function is going to cross through 0, getting from one to the other. So can we apply the intermediate value theorem to show that the equation 7 over x plus 2 equals 0 has a solution in the interval -9 to -3? Yes, we can. But let's read this thing. Yes, we can apply the intermediate value theorem to show that the equation has a solution c in the interval -9 to -3. In particular, the intermediate value theorem guarantees that there is a real number c in the interval -9 to -3 such that f of c equals 0. And the reason we say 0 here is because one of them was positive, one of them was negative, so we know it has to cross 0. So this one's a yes. All right, well, that is a little bit of work with the intermediate value theorem.